Hello everyone, this is Kitish here. In this video, I'm going to go through the AQA Physics Paper 1 Higher Tier from 2025. Question number 8 is on the topic of particle model of matter. A scientist poured some liquid nitrogen into a container. The container was then sealed. Figure 10 shows the container with the liquid nitrogen. The liquid nitrogen was at its boiling point. When 9,950 joules of thermal energy was transferred to the liquid nitrogen, 50 grams of the nitrogen turned into a gas. Calculate the specific latent heat of vaporization of nitrogen. Use the physics equation sheet. Now, the energy transferred is equal to the mass multiplied by the specific latent heat. Now, mass is 50 grams. You need to convert that to kilograms, which will be 50 divided by 1000. That will give you 0.050 kilograms. Let's substitute the value. Energy equals the mass multiplied by the specific latent heat. 9,950 equals 0.050 multiplied by the specific latent heat. Specific latent heat equals 9,950 divided by 0.050, which is equal to 199,000 joules. Explain why the internal energy of the nitrogen changed as the nitrogen turned from a liquid to a gas. Now, if it's turning from a liquid to a gas, the internal energy of the particles should actually increase. Reason: the temperature is changing. Sorry, the temperature doesn't change, but there's a change in state. Now, that would increase the potential energy. So here's the answer. The potential energy of the particle increases, but the kinetic energy of the particles does not change as temperature does not change, because there's a change in state here. So the internal energy changes. Now remember, this is probably a harder question for most students. I want to write a little bit of notes here. Okay. Now, internal energy equals the potential energy plus the kinetic energy of the particles. Now, during a change of state, the potential energy is changing. The kinetic energy doesn't change. If the temperature is changing, then the kinetic energy will change, whereas the potential energy remains constant. So here, as they say, because it's changing from a liquid to a gas, the potential energy has to increase. So the kinetic internal energy increases. After the nitrogen has boiled, the temperature of the gas increased. Now the kinetic energy should increase. Explain how the pressure of the container changed as the temperature increased. Now the pressure should increase because temperature is increasing. If the temperature increases, kinetic energy increases, which means the particles move faster. They collide with the walls of the container with a greater force and with a greater frequency. So the pressure increases because pressure equals force over area. Here's a model answer for this question. The kinetic energy of the particles increased. So particles exert a greater force on the walls of the container during each collision, and the frequency of collision of the particles and the walls of the container increases. So the pressure increases. That brings us to the end of this question, and I will see you in question number 9.